see if I get focused.
Please join me in welcoming Dan McNeil.
Thanks. Thank you, Rocky Mountain Smiths, for inviting me. I'm greatly honored to be asked to demo for you. And I have been a hobby smith. It's been my passion for 30 years. And the first time I came to a conference, I was entirely intimidated. I knew no one, and I wouldn't pick up a hammer or get close to a forge. I was really pleased to see so many at the competition and the open forge and all. It's really great to see such participation, and I wish that I had participated in that way when I first came to a conference here. However, when I first came to a conference, I didn't know the first thing about any of this. So my demo is sort of geared towards the beginner. And when I I was greatly blessed with a chance to have a master class with Francis Whitaker. And that was in 1998, 7 days of being told how to do things the right way. And so I will try to relate to that, to use some of what I learned during that 7-day period, including how to start a fire, how to make sure that you maintain your equipment. And I'll start out first by talking about the kitchen. This is the place where you work. The triangle between the anvil, the vise, and the fire is critical for your efficiency in working in the forge. And so if you have to walk around from this side of the fire to get around to the anvil each time you're working a heat, you're losing precious time. So I've repositioned the anvil. I'm going to use the fire from this side. I fashioned last night a little thing here so that I could operate the fire from this side. And this will make it really quick for me. So to start a fire, we start with some newspaper. And Francis taught me, use enough newspaper. Not too much, not too tight, but usually it's about 3 sheets of standard New York Times for me. This is a little bit smaller, so I'll use this. And I use a side draft forge at home. I love the side draft forge. I used to have an overhead forge. The side draft is much cleaner in the shop, and I find it easier to use. Light the paper outside the fire. Get it going. Turn on the fan, the blower. Cover it with Coke. I build up the coal on this side of the fire, bringing coal into a mound on this side. Constantly loosening up so that air gets into the fuel. You only want to be burning coke in the fire. The coal converting to coke is on the side of the fire. So these are the impurities burning off. Use lots of water on your coal. That helps it make coke. I asked Francis, what kind of coal do you want to have for blacksmithing? I thought I'd get a good answer. Well, actually, I got the best answer. Any coal that makes coke. Great. Hello, I'd like to have some coal that makes coke. It's metallurgical grade coal that makes coke. And other people who know more about that can tell you about it. But I know that coal that makes coke makes a good blacksmith fire. And here we go. I'm feeding from this side, and as I loosen up, I'm bringing new coke into the fire. My forge hood at home is built more like that one over there, with the smoke shelf built into it. I've heard all kinds of different stories about engineering that. I don't have a roof fan, and I have incredibly good draft with the forge hood that I have, that I copied off of Will Perry up at his shop, Pinion Forge. Today's demo, because when I took the master class, I made tongs. I came to Francis and said, "Can I take your class? What's your project?" "Well, I want to make tools. I want to make a set of tongs." And he had a set of tongs around his forge. And I said, "Well, I'd like to make a set of tongs like that." And so we ended up making over 30 pair of tongs in the week. And every size that he had in his rack, and a hammer, and a few other tools as well, bending wrench. So a pair of tongs that I did not make in that class, but I have found to be extremely useful, is the pickup tong. And so it's this design. It's useful for many things. You can pick up a drift with it. You can start a drift with it. You can hold a letter stamp tool when you're going to hit something short. I use it also, because I do some woodworking, for reaching into my wood rack and pulling out something. Or you can reach into the steel rack and pull out that piece of bar that you're trying to get with your fingers and you can't get it out. So, useful pair of tongs. I'll be using some tools and some material. 2 pieces of 1/2-inch square bar, a piece of 5/16 round for the rivet, and a 1/4-inch hot punch, and a 5/16 drift, which I just picked up and showed you. The backup plate, this is for when I do the rivet. The 1/2-inch and 3/8-inch V-tongs, which I made in the class with Francis. The bending wrench, and the vice forks. So now that our fire is going, the first thing I do is like what Steve showed us. It's a half-faced forming of the end of the bar. These are the first pieces. I'll just pass these around as we go, and we'll get started. If you have any questions as you're going on, just blurt them out, and I'll try to answer as I go. And we'll see. Yeah. Carl. Well, I figure that you can look at this when I'm not talking and I've got my back turned. You can focus on all these tools right here. And you can see them. I laid them out here especially for you, Carl. Pardon me?
Do you use mild steel for all your tongs?
Yes, mild steel. Well, not all the tongs. The scroll tongs with a really sharp point, use some spring steel for that. Alloy steels are a lot harder to forge than mild steel, and so it's generally harder to forge, and so I'm not going to use that. Identify the corner. You see where my left hand is. So, a lot of people are afraid of the metal. They reach over here and they're pounding like this. Haberman, he leans against the anvil. He's right there. I tend to be a little farther back, but I like to brace my left hand against my leg at times and strike, raising the hammer above your ear to get a good strong blow. That's not for planishing blows where you're doing choking up and doing little blows, but when you're really forging, get close. The height of the anvil. Height of the anvil should be about where, with your legs a little bit bent, because that's what you're doing when you're forging. You want the hammer handle to be level with the ground so that your hammer face is, you're hitting flat onto the anvil surface or onto whatever you're forging. And so this is actually a perfect height for me because I can come down and it's flat and it's square. An anvil that's too high, you're going to end up hitting like this all the time. An anvil that's too low, you're going to end up hitting like this all the time. And if you see a hammer that's all deformed on the front edge, that's from somebody who's been hammering down like this, and it's all deformed on the edge. Now you'll notice this hammer. It's different from most of the hammers you'll see around here, with a diagonal peen. I made this so that when I'm drawing things out, I don't have to be like this when I'm drawing it out. I can draw it out in a comfortable place and get the same drawing motion from the fuller on the back of the hammer. So, the next step that I do is this one, where my first was a half face here, then I turn to the left and go to the opposite side of the anvil. At this point, it's really easy to get the part that's next to the edge of the anvil too thin because you're hammering down and you can point the, so I'm working the heel to get a nice parallel face there where it's going to be the boss for the jaws. Now, I would have gotten in trouble from Francis had I done what I just did here. Can anybody tell me what it is? I left the blower on. You're right. Coal is a non-renewable resource. Don't waste it. You see all this coal down here on the floor? He got irate when there was coal on the floor because the forge is not a coal bin. And too much coal up here, it falls over on the floor and it's a big old mess as well as a waste. I'm making the kind I make. Let's see here. Next step is identify the back edge of the boss. Pardon me?
Did you say it was okay just to ask questions?
Yes, absolutely. Ask questions.
What's the index point on the far edge of the anvil for the second shoulder?
Like in the box jaw tongs, And here I'll explain what I've just done. The first step was about 1.5 inches, maybe 1.25 inches. Depends on what the length of your jaw is.
Right.
All different kinds of tongs will have a different jaw. And so the first one has a lot to do with what kind of tongs you're making. For this one, it's about 1.25 inches that I started with, and at this point, it's more like 1.5 inches. It will get longer for these as I taper it, and that's my next step here. Then I turn to the left and go on the diagonal when I'm making the boss with the first one, and then I'm turning to the left again, and the index point is behind the first indent. The second is about 1 inch, so that from here to there is about 1 inch.
Yeah, I understand those dimensions. What I was referring to is after you form the first shoulder, and you turn a corner, turn to the left. And you lay that across the far side of the anvil.
How far do I go across? What I've done is
What are you looking for there?
just a little bit back of the, where's my first sample piece? Yeah, let me have the first sample piece. What I'll do is I'll put the anvil right about there.
Right at the point of the first shoulder.
What camera? Right about there. Okay? Does that make sense?
Thank you.
It's at this point that I begin to really do some good shaping on this part before I draw out the reins. Because if you don't do the part at the jaw now, then it's harder later on. So, like what Gordo said, what's going to be harder later on, do now. Work on all your tax paperwork before the 15th of April. And because this next step is critical for me, I have this piece which helps me to know the angle that I'm working at and what I'm trying to achieve in terms of drawing out this part and this curve going into that curve, and from down here coming up and into that curve. And so that you know what I'm talking about, here I'll pass around those two pieces. I'm using the fuller side of my hammer, and then I flip around and use the flat. You heard from Gordo yesterday, and you'll hear from me today. Get it hot and hit it. Don't let it be too cold and try to forge it. It's a waste of your time. It's kind of like teaching a pig to sing. It's a waste of your time and it annoys the pig. Okay. in prepping for the demo, I actually worked on 10 pieces at the same time to make all these little sample pieces. Then I dropped off. But earlier on, as I was relearning how to do this, because you have to be, practice quite a bit to get good at something. And how many people are making tongs all the time? I made them, 16 years ago, and made them a couple of times since then. But I will work on one to a certain point, then work on another to the same point, and then bring them together. And that's actually what we're going to do today, because I figure that some people will like to see this twice. So the first time is the first half of the tong, and second time you see the second half of the tong. But I won't talk as much during the second half. I can. So what I'm doing here is I'm bending this down so that I can get this nice little curve going here. Of course, it's easy to make the first of something. Making the second one to match it exactly is the hard part. So I remember students would come up to Francis and say, "Look what I made." And he said, "Oh, great. Go make another one just like it." So I don't know if you can see from this camera over here, I'm loosening up the fire. And each time I loosen up the fire, more air comes into the fuel, and it helps the fuel burn more efficiently. It was really nice that Dennis Dusick just published in, what's the publication that just came out from Urbana? The Hammer's Blow. His tongs, because I picked up some pointers from that article. I'm always learning from other smiths, as I'm sure we all are. So it's really handy to be able to compare and see how I'm doing with the shape and the angles, because my eye's not good enough to remember exactly what it should look like every time. Quiet crowd. Must be like, right before lunch.
Just a good demonstrator.
How do you like the flat range?
The flat reins, these right here. I do round the edge where my hand is, because it's nice to have a rounded, surface for your hand, because it's more comfortable. But a fully round doesn't make engineering sense to me, because it needs to be strong in this dimension more than in this dimension when you're using the tongs. And so you actually gain some efficiency. Now, it's really easy when you're doing this. What do I do with my measuring tape here? Oh, there it is. Yes. It's really easy to get this part too thin. And that's going to be the part that has the most stress. it's easy to get this part too thin, the part with the most stress for when you're binding down on something. And you can just imagine, I'm holding on to this, and as I'm squeezing, it's the part that is right next to the pivot that's the thinnest, that's going to have the most stress on it. And so you don't want that to get too thin. Then as I'm going out from there, the bending moment lessens and lessens as I get to the end of the reins. So I can be thinner out here, except that I don't want to be so thin that it hurts my hand when I'm holding the tongs. So you find a happy medium between being thin for lightweight and efficiency and length and use of material, and making your hands feel good. So there we are. We've got the shape ready for the hole. I've rounded this part here in preparation for getting that shape into the jaw of the tong. And we've got this little boss down there, this little, what do you call that? I'll call it a pooch out, little pooch out there that allows for when you put the tongs into a rack, it doesn't just splay out, but it actually sets, and it's easier to arrange in your rack, in your tong rack. So, next step, I'm going to switch to my 3/8 V tongs to hold this jaw, and then we'll draw out the rein. I generally draw out the reins at a power hammer, but because I'm doing this demo for rank beginners who have only a hammer and an anvil and maybe some of these tools, if you don't have tongs, you can use vice grips. You can get vice grips at the hardware store. There's a lot of different modifications you can make to vice grips. One of the modifications that I've made is to grind the jaws and braze in copper. This is for another operation I'll do this afternoon, but a copper jawed vice grip doesn't mar your iron work, and it's very handy. You saw the tong clip that we talked about yesterday. I find it's kind of big and it falls off easier. And even though my mentor, Francis, promoted it a lot, I kind of like these little bent tong clips better. So I'm going to now draw this out on the horn. Now, I'm not going directly perpendicular to the axis of the anvil. I am tangent to the curve of the horn at the place where I'm forging. It's now getting too cold to be easy to forge. So I'll take another heat. Straighten it out before you put it back in the fire. You got it, Carl?
Yep.
The tong clip helps to preserve your hand, and you don't have to squeeze it in order to get it on. You can lay it on the anvil and push down with gravity. Hammers come from the store with edges on them. They're ground with square edges. Are there any square edges, sharp edges in nature? No. And because we're making organic shapes, even if we're trying to make architectural shapes, we're forming them organically like clay. So having relieved the edges and rounded the edges of your hammer so that if you have a little misstrike, you don't get a sharp cut, because you don't want a cold shut in your work. A cold shut is where material will fold over itself in your forging, and that will cause a weak spot, which will eventually cause a break. It certainly looks bad in the finish. And if you're forging out of files, if you're making anything out of a file, you need to grind all of the file, teeth off until it's smooth before you start forging, or else you'll have a failed project from the get-go. Now you know that this is a long, drawn-out process. And at this point, I'm getting a little long for one heat and trying to forge the whole thing. So I'm going to forge this end next, and then I'll come back up and forge this end. My goal is to get 12 inches from this point to that point, and to be a 1/4 of an inch thick here, and about 3/16 of an inch thick there, to be about a 1/2 of an inch here, and about 3/8 down here. I probably do. You could almost never have too much water on the coal, but if the coal isn't coking up and really getting kind of chunky there, or if the fire's just getting too big, you can help, get the fire down a little bit. This is a Tennessee watering can. It's got holes across the side over here so that I can dribble and kind of spray it as it goes. See that? I find these are way heavier than what I like to use. I like to use a coffee can, and of course a lot of people say, well, it rusts out. Well, not if you empty it out each time, and since my forge, my smithy is not heated, everything freezes in the wintertime, and so I just always empty the water out, and well, except now you get coffee in bags instead of in 1 pound cans, so I don't know who buys those 1 pound cans. So as I'm forging, you'll see that, I'm tapping well, that's just because I want to let my hand relax a little bit in between our blows. So I'm not trying to, be fancy or anything. It's just that's the habit I've gotten into so that as I'm looking at or in between blows, I don't have to be suspended the weight of the hammer on my hand, and it helps to relieve the fatigue on my arm. Carl, do you want it here or here? Just teasing. Was that good? So, one thing that the water helps do is it helps the angle of repose of the mountain of coal next to your fire. That'd be some geologic speak. Angle of repose has to do with the sand pile, and the angle of the sand dune has to do with the angular structure of the sand crystals. I started out with Rocky Mountain Smiths, and one of the first things I did was the Sandia Forge workshop up at Randy Calhoun's shop in Wyoming. And we built a whole bunch of gas forges together, and Rob Gunner was there. And I thought, wow, I'm in business. This is great. I love that gas forge. And I still have it, still use it in my shop at times, but I don't do production work. I do one-off stuff. And I like the coal forge because you get a specific heat in the place where you want it to be. So when you're working on stuff, and I might want to have done this earlier on, is know the dimensions in and around your anvil. We're 4 inches wide there. Okay, if you ever need a 4-inch, you're 1.5 inches to the edge of the hardy hole. It's 3/4 of an inch to the edge of the pricktol hole. But there's nothing that's a foot until I put a mark there. Then I can say, okay, how close am I? Well, actually, pretty darn close.
Why'd you measure?
To show you that it's not luck. No, it's not luck, it's simply blessed good fortune. Now I'm going to knock down the corners on the back, or on the part where my hand's going to be. Sometimes I do this in a bottom swage, but because beginners don't usually have bottom swages, I'm just going to do it by knocking down the corners with a hammer. We don't have to be up to quite the forging heat that we would be if we were really moving metal, because really all we're doing is planishing the surface of the metal. Using lighter blows, I'll still use my bigger hammer. I've got 2 hammers here. A specific reason why I would want to use the smaller hammer at times. When you've got metal in the forge, you don't want the metal poking down into the bottom of the forge because there's no fuel underneath it. You want the metal to be, the iron, to be straight across in the forge. So there's a good amount of fuel underneath and on top. Don't drag green coal up and over and into the fire. Bring the green coal up and loosen the coke up that's been forming, and it will fill into the fire. You can see here, my coal factory is over here forming coke, and there's very little on that side, but there's enough for the fire for sure. Gordo learned with an overhead forge and likes to have the coal all around, but with a side draft forge, I've found that this way works better for me. Everybody's going to have a different way of doing things. I had to think there for a minute about which side my hand was going to be on. Constantly looking at what it is that we're doing, reminding myself of the big picture. Now you'll see how this is, by striking on the one side only, I have formed the curve on here. Well, for me, I'm just going to straighten this out. Sometimes that's desirable. You want to do that. Sometimes you don't want it to do that, and specifically, you will work at striking on both sides. I don't really need to do the upset edge on the inside of the tong, so I'm not going to worry about it much. But after I've done that, I'm definitely going to knock down the little upset edge that occurs when you upset a corner. Because I don't want any sharp edges to hit my fingers. Okay, so I'm straight there, and I've got my shape up here. Next thing I'm going to do is do a little more shaping here then I'm going to make the other one, then I'm going to punch the 2 holes and put them together. I don't quench unless there's a compelling reason to quench, because if I later come back with a drill or a saw, it's hardened and it can affect how strong things are. I just tend to leave it like it is. Let it air cool. Mild steel, air cooled, is relatively soft. Keep the face of your anvil clean. Don't let scale build up on it unless you want scale in your work, because as clean as your hammer face is and as clean as your anvil face is will reflect in your work. And when I say reflect in your work, what I mean is it will reflect in the finish of the surface of your work. If you want to really learn the shape of something, draw it. Don't trace it, draw it. Draw it by looking at the piece and then drawing it on a piece of paper. When you're done, compare the original piece with what you've drawn by laying it on top. See how the angles are off? So I look at it and say, okay, where do I need to adjust? If you can see in your head ahead of time what you're going to do in the forge, it's a lot easier when you get the hot iron out here on the anvil. That's why drawing the piece, you've already made the piece in your mind by drawing it. And tracing it is great to get a record of something that you've seen, but actually sitting there and drawing it, it's a lot better for your memory mind. When you're doing scroll work, it's a similar process of work on the scroll and then check it to your drawing, check it to the one you're trying to match. Work on your scroll, check it to the one you're going to match. I like having the wire brush really close to where I'm working, and I haven't been wire brushing every single time I come out of the fire. But I like having the brush right here where I can pick it up and do this and drop it back down again. I don't like having it underneath here and around in different places. It's like right there is where I like to have it. So this one is ready for the next step. Now, I'm not going to talk as I do this next one, but you can see each of the steps that I'm going to do from what I've already talked about. The height of my forge at home, I have of course, I'm the traditionalist. I copied my master. I have a dirt floor. Does anybody know that it rained this year in Colorado? Even though I've got a French drain running right down the middle of it, still we had a lot of buildup of water in my shop, especially underneath the forge, and the forge was sinking. And I realized that the forge was lower than it used to be. And that's why I was getting a backache while I was trying to do forge welding, because I'd be looking in there and leaning over, and I was leaning over farther than I needed to be. And so the height of the forge for me, and my eyesight and my height and build, was better to be raised up 3 inches from what it was. And I found that made a huge difference in my working at that particular forge, which is more like the height of this one right here. I like this height a lot. So it goes to show when you're doing the refrigerator and the sink and the stove in your kitchen, make sure it works for you so you can work efficiently. Steve taught us if we're going to square it up on two sides, it's less likely to be crooked. I'll try to remember that. Loosening up the coal lets air get into the fuel and it burns hotter and more efficiently. In doing this action, it also pushes the clinkers to the far corner of the fire, makes them congeal, allows them to congeal together and melt together, form a larger clinker on the far corner of the fire, and it's easier for me to get out. I happen to have coal that forms a lot more clinkers than this does. This is great coal. Where does this coal come from? Pocahontas. Is that West Virginia? They're going to make him change the name of that mine now that, proprietary Indian names are really, a hot political thing. Okay, I was here, turn to the left. Has anybody had any hearing loss? Has anybody had any hearing loss?
My hearing aids shut off at 80 decibels. They make good blows.
Use ear protection. I thought tongs would be formed at the jaw and then the reins welded on. Francis said, "Why do that? I have a power hammer." He liked to forge weld, but didn't think forge welding reins was worth his time. This way, and now this way. So I've just finished the second offset. Who can tell me what the next step is?
Drawing out that handle.
I'm gonna form the jaw better. I'm gonna do more work on the jaw. I formed the second step. Now I'm gonna do this part.
It's a box jaw, Tom. It's a jaw to stand or you do box thing. If it were a different style jaw, would you still work on it at this point?
Until you have the right setup. Yes, a box jaw tong, you'd be working the two different pieces a little bit differently because of the box. Anybody have back trouble? As you're standing, if you keep your legs a little bit bent, don't try to arch your back, but just keep your legs a little bit bent, you'll stand straighter. It's the same thing as lifting with your legs when you're lifting a heavy load. Stand as though you're lifting the load, because you're lifting the load that's the upper half of your body. It helps. Always protecting that offset. I don't put the little curvy thing at the end at this point because I need to be able to hold it for the next step. And when I'm holding it, I'm using the 3/8" V-jaw tongs, and I'm holding it on the angle here. And it's not the best connection, but it works pretty well. Tongs are an extension of your hand to hold the hot iron. Different pairs of tongs will hold different sizes of metal and make it, you want to hold it really secure. You don't want to hold something like what I've just been doing with the tongs, the style I'm making, even though I can pick it up, it's all wobbly in there. It's going to fall out. I get a lot more efficient work done if I'm able to hold it super secure as though I were holding a longer piece with my hand. It was 4 heats to draw it out on the horn. I'm going to draw it out on the Little Giant for the second one. Not that I don't want to show you pound it again 4 heats here, but just for the sake of the demo, I'll show you the Little Giant. Now, I would show you on the Big Blue over here, but I don't think it's a good idea to do a performance without a rehearsal. And I haven't used that tool before. So before I show it in front of everybody, I'd like to have a chance to try it out before I perform. It's always a good idea to have a rehearsal. My background is in the theater. I worked in technical theater for almost 40 years. And over 40 years, you do a lot of plays when you're, just figure it out. 12 to 15 plays a year, 40 years, okay. I've seen a lot of performances, and we rehearsed for every single one of them. And it still didn't keep us from having accidents and mess-ups and mistakes. But you try to get it as good as you can because you're working with a lot of people. It's collaborative work. You're working together. Everybody's depending upon everybody else. I mean, you know what it's like working with a team, especially if you're doing a striking team. You got to know how to have the cadence so that somebody doesn't get hurt. Not bad for a beginner. So, my Little Giant Fit 25 pound does not have a brake on it. And it's a lot slower startup, and of course it slows down as well. When I started using this last night, I realized that if it's been sitting for a while, the very first strike is super hard as the brake releases, which is why I did what you're not supposed to do, which is start the hammer with nothing underneath it, but I didn't want what was underneath it to get too hard of a blow. So in order to get good, soft, finessing blows, I needed to actually have the hammer running a little bit. So that's why I did that. And even though I've done the reins out on the Little Giant, I'm now going to knock down the corners and planish out the heavier blows of a power hammer. Whenever you're trying to straighten something out, if you have a curve and you want to straighten it, put the curve on a flat piece. Now, the flat piece could be the anvil, but you want both ends of the curve, like an arched bridge. You want both ends of the curve to be touching the anvil, and then you strike it in the center to bend the curve out of it. Don't try to straighten out the curve by turning it upside down like a U shape and hit on the far side, because it's just going to hit your hand up. It's going to be a lot harder. Turn it over, have it be like an arch bridge, and hit it from the middle down. I'm sorry, it's my wife calling. No, just kidding.
For fine finesse of things that won't flatten on the flat of the anvil, putting it over the hardy hole and hitting it.
Yes, you can get more of a straightening over the hardy hole. The temptation is you've got some heat in it. Okay, I'm going to continue to bend it. The less heat, the harder it is to bend. And I generally bend it where I don't want to be bending it when I don't get some more heat in it. We've not seen hot punching this weekend. But Steve talked about it a little bit today. He also talked a little bit about when he was slitting that drift in the box jaw tongs, box jaw pliers, that he used to hold the tongs between his legs, and that was sort of like this. But you got to be tall enough to make this work. Did you hear that? That was when it hit the bottom. I want to protect that little offset. And the little itty bitty piece that just came off, which is hot. You see that, Carl?
Hang on. Hold still. Got it.
So what I was doing there was with this, which is a round punch, probably made out of some tool steel material that I made 25 years ago that might have been S7. It could be a piece of spring. Francis would always say, spring steel is for springs, tool steel is for tools. And H13. So what is the difference between 5160 and 4140 and H13 and S7 and, well, what's the difference between a meter and a yard? Well, they're both about the same. They're a measurement, and it's a different standard. So the lettered series are a different standard than the numbered series. In the numbered series, the last two numbers might mean the amount of carbon content in points of carbon. 100 points of carbon is 1% of carbon. The first two numbers have to do with the alloy, and I can't tell you what really they mean. Somebody else can, but that's not for this discussion. And suffice to say, know your steel, know your alloy steel, and know how it gets heat treated and how to use it, because it can surprise you by, if you get it hot and you quench it in water, it might then do something like get soft or break because it's so hard. You don't want tools to break and shatter and fly all over the place, because flying metal at high speeds can be dangerous, right? I'm not pulling the coal on top of the fire. I'm pulling the coal up to next to the fire so that it can make coke. And then I'm loosening up the coke. Sometimes I have to break up the coke because it coked too well. I need smaller chunks. But I'm loosening it up. I'm not pounding it down. I'm not squishing it in, trying to get it down there. Gravity does that for me. I just loosen this up. When Dan Nibbling was in Francis's class, okay, take a picture of Dan. Oh wait, he's not right there. Francis, one of the things he took away from the class was hold the iron over the fire where you want the part to be hot, and then put it down in the fire. Don't push it in this way, but hold it over and bring it down into the fire. Then bring the coke around where you want it to be. That does two things. It puts the fire where you want it, or puts the iron where you want the fire to be, and it keeps from pushing all the coal and the coke off the edge on the far side, because every time you push into the fire, it pushes it over there. My backup plate, I'll tell you about it later. When I was in Francis's class, we drilled all of our holes. But I thought that for the sake of what we're doing here, I'd punch the hole, because demos by the drill press just don't look as good. Yes, there's an upset. This upset right here makes it so that what I want to do is punch down from here because this side is flat. So I'm punching down through there, and then I'm very careful when I'm turning it over to protect this upset. Okay, so I totally screwed up. I forgot to do the drift. But we'll do the drift now. Now, I picked up the drift early on with tongs and showed you, and I put them underneath my file.
What size drift is that?
This is a 5/16 drift. I was punching with, a little bit bigger than a quarter. Because I punched through from this side first, it's a little wider on this side than it is on that side. I'm going to turn it over and drift from this side. My drift is mild steel material because I don't want it to damage my forging hammer face. Notice, I'm protecting that offset corner by always having it over the edge of the anvil. Now, since I just flattened that out, it now is smaller, so I'm going to drift it again. Is it hot? You bet it is. That's why you pick it up with the pickup tongs and cool it down before you use it again. I like having a surface really close to my anvil so I don't keep dropping stuff on the floor, because each time I pick it down and up, it's wearing and tearing on my stamina. Now, if you really like doing deep knee bends, put everything on the floor and just pick it up each time you want to use it. Otherwise, get yourself a table. There's an end to this drift, which is narrower, and that's the part that goes in first. And there's a part that is still tapered so that it falls through, but that's the part I hammer on, and it gets mushroomed out Now this has a pretty good hole in it for my 5/16 to go through when I finally put the pin in. Here you go, Carl. We will do an offset. And for this, I'll work in the vise. One of the things Francis was always ragging on about was oiling your machinery. Keep the threads of your vise oiled on the inside. Keep the joints oiled all over the treadle hammer. Don't pick it up. You see, my dirt floor, that never happens. It goes down to the dirt and it sticks. Of course, it's dirt. Things are dirtier.
It also makes it easier to roll something across the
Oh, it's much easier to roll something on a cement floor. There's advantages to both. I just thought I'd, give a little plug for the old-fashioned. Well, but you sometimes have to dig another French drain when there's too much water in it. That was this spring.
Purely for just if the floor catches on fire.
Francis liked a dirt floor for a number of reasons. One was that they didn't charge you as much for property taxes. So now the offset. And we're going to offset toward, okay, like Gordo said, do it the way you always do it, the same way as you're bending with things. And so I like to hold it in the right hand with the forks going up. That helps to get a straighter bend. And I'm always pulling towards me because I have more control. I'm pulling towards me. So what I'm trying to do here is I'm trying to offset towards the center of the jaw so that the center line of this rein lines up with this face of the boss. Okay? Dan, would you get a striking hammer? The backup block can get hot. Anything that touches hot metal can get hot. You'll remember that when you pick up something that's hot. So, Rob Gunter held a class. I wasn't in the class, but he invented this way of making touch marks by taking a piece of hex and making your touch mark, and then taking an Allen wrench that's been straightened out and putting it into, numerous times, putting it into your positive, into your negative so you can form a positive so you can then punch a negative. So I've been using this ever since I read the article and followed the directions.
You know, if you're doing coining, that's what they do.
So I want my touch mark to be on the outside where you can actually see it. Yeah. Okay, hold it with my left hand. Right hand's a little sturdier, steadier. Not 2 hits, 1 hit. Thank you, Dan. So now we will bend this. My first bend is offset towards the center line. My second is offset to straighten it out. Do they look the same? They sort of do. Remember, anything that touches hot metal could be hot. Like that fork. When you're filing, you know, it's going to cut when you go away from you. So don't drag it with full force as you come back. But I'm also not a purist where it has to like not ever be touching during that process. I'm just not putting down force on it. You hear about hot rasping. Well, that comes from having Farrier's rasps that are old and unusable, and they're great. This file is wrecked for normal purposes, but it works pretty well for what we're doing here. So, one of the first rules of working with tools and machinery is if it's moving really fast, don't touch it. Right? If it's sharp and moving really fast, really don't touch it. And in the forge, if it's hot, don't touch the hot part. So at this point, there's no metallurgical change going to happen when I cool off the rains. Because metallurgical changes happen at higher temperatures. Yeah, okay, well, 5 more minutes. We started 5 minutes late. Okay, we are ready. They line up. It's the average person who learns from his mistakes. It's the exceptional person who learns from other people's mistakes. And I'm not saying I'm exceptional, but I'm going to find a Hardy that doesn't stick. Never hammer with the Hardy in the cutoff. Never forge with the cutoff. What could happen? So this next step, 1¼ inch. That's what I want. Why do I want 1¼ inch? For my rivet. Well, because of what I'm doing with the rivet head, I actually want one length of the diameter for each side, plus a little bit. Yeah, 1½ inch. And then the thickness of my material. My material is ½ inch thick. I want about 3/8 on each side. So I measured. I cut almost all the way through, but not all the way through. I've got a perfect handle for my little rivet. It's really hard to heat up something that's this long in the forge. Besides, when you grab it with something cold, it's going to cool off right away. In my class with Francis, we did all of our drilling of the bosses, and then we used round head rivets and a torch to heat them up and put a round head on the other side. That's not this style of rivet. This style of rivet is what you can do when all you have is a piece of rod. It'll heat up hotter, faster on the bottom side of the fire. So I'm aware of what side is down so that I'm keeping both sides heated evenly. That's why I'm turning it over. You want to line them up so that they're straight. You want to make it so that they pick up what you're supposed to be picking up. And at this point, so that's what I wanted. So after lunch, I'm demonstrating again for an hour and a half, and I'm going to make a candlestick that is a surprise. Have a good lunch.